Okay, here we go. So we've got a circle, and remember, this is pizza, right? And it's 1/8 of the whole entire pizza. So we're not finding the area of the whole entire circle. We're finding an area of how much? 1/8 of it, right? 1/8 of it. So how are we going to do that? It's 1/8. What? It's area this time.
So divided by 360.
You don't have to. You already got an eighth. You don't have to divide it by 360 because you already know the fraction of the whole circle. It's not 2 pi r. It's area. We're trying to find the area of one slice of pizza. Okay? Yeah, pi r squared. So it's 1/8 times pi r squared. Okay? Now, if I was going to do the math, I would do it like this. I would go pi, the radius is 6 squared. Instead of multiplying it by 1/8, would be a little bit easier to do what? Divided by 8. It's the same thing, isn't it? All right, so you can chuck that in the calculator. Let's see what we get for that. We get, well, you know, you can do that in your head, can't you? 36 pi. Right? 36, and here's the pi button right there. 36 pi divided by 8. And there it is, 14.1, 0.1, right? Because it's 1, 3. So we'll go 14.1. So 14.1. Actually, they tell you to round it to the hundredths place. I didn't realize that. So it's was it 137, right? So it'd be what? 1, 4. Okay. This is area. If this was inches, it's a 12-inch pizza. So what was your area going to be? Inches squared. All right, there it is. That's one way to do it. You could do it another way. Watch this. What if you didn't realize, oh, this is 1/8 of a pizza? You could do this, though. You still kind of have to realize it's 1/8 of a pizza, but you could still do it in degrees. How many degrees do you think this is right here? It's 45. How'd you do that? Exactly. It's 360 divided by 8. Okay, so 360 degrees divided by 8 equal pieces, right, is going to give you 45 degrees. So if you order a pizza and you got a protractor with you, stick the protractor on there and see if it's 45 degrees. If it's 45 degrees, then it's cut perfectly even, isn't it? All right, if it's more, then you got a bigger slice. If it's less than 45, you got a smaller slice than you're supposed to get. Jordan?
What if they don't tell you this on pizza?
Well, they would tell you something. They would tell you like what part of the circle, or they would tell you what the degrees is, you know, that kind of stuff. So yeah, they would definitely tell you something here. It's not always going to be 45, obviously. I mean, they might say, okay, here's a circle with a 27-degree angle in here. All right, so what would you do? You wouldn't go 1/8 or anything. You'd go, right, you go 27 divided by 360, wouldn't you? So on this one, watch, what would you do? You would go 45 divided by 360 pi r squared. Now, what is 45 over 360 anyway? Still 1/8, isn't it? All right, so on this particular problem, yeah, I would have used this. But you can figure out, right, if they tell you this angle, I mean, again, for instance, let's just make up a weird angle. Let's say it's 37 degrees, and I want to find the area of this. By the way, I didn't say this in the last class, and I meant to. They give a name for this. They call this a sector, S-E-C-T-O-R. Okay, that's a sector. It's a chunk. It's a piece of the pie, right? Piece of the pizza pie. All right, that's called a sector. And if they give it to you 37 degrees, what do? You just go 37 over 360. Now it's area, so it's pi r squared. Everybody with me on that? All right. Let's do one style of problem. They don't give you an example on this, but they do ask you to do some of these problems like this. So let's do one more style of problem, and then we'll be finished. Okay, here's the deal. Here's the last situation right here. They don't give you an example in the book, but they do give you some problems that look very similar to this, all right? So here's one situation that we have. Let's say the diameter of, oh my goodness. Look at that mess. I forgot to change this stuff up here. Let's change it back to black. Okay. Oh goodness. Now why is it doing that? I thought I changed it. The fill is 0, strike. Oh, I know why. Because I made my point size like 20 point, and I forgot to change it back. Let's try one more time. Diameter. Ah, there we go. The diameter is, I don't know, make up a good diameter. What would be a nice easy number we can work with? 20? Okay. Well, we used actually, we used both of these already. Let's use something else. 60? Okay. Jordan said 60. We'll use 60. So the diameter is 60. What we want to do is we want to find the area of this shaded region right there. Okay? Actually, let me take a look at this. I got to tell you one more. Actually, I'm going to tell you one more thing. So that's 60. I don't know. What do you think this is right here?
That'd be like
55? Let's go 50. Is that all right? Okay, so we'll say that's 50. What we want to do is now find the area of the shaded region. You got to know a couple things that we've talked about in previous lessons. Mariah, you with me? Snap her out of it, please. Come on. All right, let's take a look. So what we want to do is we want to find the area of the shaded region. What we're going to do is find the area of the whole entire circle. Now that's not just the shaded part though, is it? That's everything. Then what do we want to do? Jordan? Yeah, subtract from this triangle. That's right. Find the area of the triangle and subtract that from it. So let's find the area of the circle first. So the area of the circle is pi r squared. And somebody have a calculator at the ready? Give me some numbers here. So it's going to be pi. What's the radius of this circle now? The diameter is 60, so the radius is 30. And we have to do what? Square it. Somebody do that. It's 900, right, times pi. Give me that number. Give it to me as digits. What is it? 2 what? 27.4. Okay. And that's, we'll say it's inches. So it's square inches. That's the area of the whole circle, right? We'll even put a C there for circle. Is that okay? Now let's find the area of the triangle. How do you find the, we'll put a T for triangle. That looks ugly, but it's area of a triangle. What's the area of a triangle? 1/2 times the base times the height. Now look at this. Do we know all that stuff? We don't. But look at this angle right here. What does it look like it should be? Looks like it's 90, doesn't it? Is it 90 or does it just look like it's 90? How do you know it's 90? Because of the rule. You're exactly right. It's an inscribed angle, right? And the inscribed angle cuts off 180 degrees. Remember, the inscribed angle is half of the arc that it cuts off. So it cuts off this 180 degree angle. So that must mean that this has to be 90 degrees. Not just because it looks like it, but because of something that we learned earlier. Okay? So it's a right triangle. So if this is 50, what's the length of this side right here? That's 60, isn't it? Because that's the diameter. What do we need? We need the height. This would be the height because the height and the base are perpendicular to each other. So we have to find this. So let's do that. How would we do that? We don't. Pythagorean theorem. That's right. So what do we got? We'll call it x. Okay. So it's x squared plus what? 50 squared equals 60 squared. Okay. So it's 60 squared minus, my pen's getting real shaky now, minus 50 squared. Okay, equals x squared, correct? Take the square root of all that. Sven, you getting that for me? 60 squared, then minus 50 squared, and then take the square root of all that. 33.2. Okay, so that right there is 33.2. Now, why in the world did we need that? Because we're trying to do base times height, aren't we? And we knew the base was 50. Now we had to find the height, which is 33.2. So let's plug that stuff in. So the area of the triangle is 1/2 the base, which is 50, times the height, which is 33.2. My pen is really acting slow right now. It's bugging me. So Sven, you got it? Half of 50 is 25 times 33.2 is 830. All right, good deal. So that's the triangle. So watch, the triangle is 830. What's the circle? What's the area of that whole circle? That's the 2827, isn't it? 0.4. What do we do with that 2827 and that 830? Subtract them. So somebody do that. It's 2827.4 minus 830, and that gives us, Sven? 1997. Point what? 4? Okay. And that's the area. If you inscribe an angle, remember that the angle, when it's touching this right here, see it hits right here, and it comes and it hits right here. What's the arc that it cuts off? 180 degree arc. Why? Because that's the diameter. So you know it's 180 degrees. The inscribed angle is always half of that angle that it cuts off, the arc that it cuts off. Of this big arc. This arc right here is 180 degrees, right? So this angle is half of that arc. Half of 180 is 90, so you know that's 90 degrees. Okay? Let me give you your assignment. Record that. All right, so there it is. There's your assignment. 785, 786. We're doing 14 to 23. Then you're going to go to 32 and go through 37. That's it. We good? All right. Everybody wake up Mariah.
Mariah. She's awake.
Okay.